Chapter 9, Section 4, Part 1, begins with different types of reactions. We're going to discuss combustion reactions, which are a type of oxidation reaction, synthesis and decomposition, and then also displacement reactions, which are also called single replacements, or double displacements, which are also called double replacement reactions. So for a combustion reaction, it's a very exothermic reaction, meaning that it produces a lot of energy, and it's usually involving oxygen as a reactant. The products are always going to be carbon dioxide and water. So an example would be something like this equation here. This is a methane molecule, CH4, combining with oxygen to make CO2 and water. Also, you can see that there are a number of kilojoules of energy being produced here. So this is a very exothermic reaction. Now, oxidation reactions are not quite as dramatic as combustion, but still involve oxygen as a reactant. So, for instance, the rusting of iron, it's just the combining of iron and oxygen to make iron oxide. That greenish color to the Statue of Liberty, that's copper and oxygen combined to make copper oxide. So there's not a ton of energy being released. It's just kind of a slow, steady process instead of the very exothermic reaction that you get with combustion. For synthesis reactions, these are ones in which you take either individual atoms or smaller molecules and combine them to make a more complex compound. So just a kind of general formula, A plus B gives you compound AB. Here I give you the example of iron plus sulfur gives you iron sulfide. So combining smaller pieces to make a larger compound. Polymerization reactions are a series of synthesis reactions that are used to make really large molecules or polymers. Each of the individual components that get combined are called monomers, and by joining all of them over and over again in synthesis reactions, you get this very large molecule called a polymer. Decomposition reactions are the exact opposite of synthesis. Instead of combining things to make a larger product, you're going to take the larger substance and split it into pieces. So a single compound gets broken down to produce two or more simpler substances. So compound AB splits into A and B. Water splits into hydrogens and oxygens. A displacement or single replacement reaction involves a compound and a single element as your reactants, and the single element is going to try to replace one of the elements in the compound. If the single element forms a cation, it will try to replace the cation in the reaction. If a single element forms an anion, it will try to replace the anion in the reaction. So in this equation here, I gave you aluminum and copper chloride combining, and what will happen then is this single aluminum is going to try to replace the copper. Now it'll try to replace the copper because copper is positive and so is aluminum. It could not replace the chlorine because you can't have copper and aluminum combining with each other. The positives would not attract. So if aluminum replaces copper, you then would make aluminum chloride, and then the copper would be left by itself. The activity series is a list of the order of activities or the tendency of atoms to react with water and acids. So it's telling us how reactive certain substances are. Now, if you look at the activity series that I gave you in class, you'll see that we'll use this to predict whether single displacement reactions will happen or not. So anything that is higher on the list is more reactive, and anything that's lower on the list is not as reactive. So if you look at this equation here, we've got potassium and magnesium oxide. So you see a single element and a compound, so automatically you should be thinking single displacement reaction. So we need to see if potassium will replace the magnesium in this compound, since these are both our positive ions. So potassium is actually higher on the activity series than magnesium is. It's higher on the list. So potassium will react and it will kick magnesium out. So magnesium will be left by itself, and potassium will now join with the oxygen to make potassium oxide. So if it's more reactive, it will replace the less reactive element. If this element were less reactive, if it were lower on the list than magnesium, then we would simply say that this reaction does not occur and you would not have to predict what the products were. Also, another note is that the farther away the elements are on the activity series, the faster the reactions are going to happen. If they're very close to one another on the activity series, then that reaction will occur more slowly. Here are just a couple other examples. This one has magnesium trying to replace copper. So we find magnesium and copper on the list. Here's magnesium. And down here towards the bottom is copper. So magnesium is more reactive, so it will combine with the oxygen and copper will be left by itself. And then for this one here, we've got tin and calcium oxide. So tin is down about the middle of the list and calcium is up higher on the list. So in this case, calcium is more reactive, so it wants to stay combined with the oxygen and the tin won't be able to replace it. So this reaction does not actually occur. The last type of reaction is a double displacement, and that is where you've got two compounds as your reactants and then you'll produce two compounds. So the two compounds that you start with are basically going to flip cations. So A and C here will switch partners. So now A and D will combine and B and C will combine. So in this real example, we've got potassium iodide combining with lead nitrate. So the lead and the potassium are going to switch spots. So lead will now combine with the iodine and the potassium will now combine with the nitrate. And then here are just a couple examples of some different types of reactions. So this one, we've got two compounds, so we should be thinking double displacement, which is the case because we've got our sodium and potassium that flip-flop. Here we've got a hydrocarbon, which is a carbon and a hydrogen compound, which is required for combustion, and oxygen. And then we know with combustion reactions, we also will produce carbon dioxide and water. So this one is combustion. You could also say that this is oxidation because oxygen is involved as a reactant. For this one here, we have a single iron combining with a compound. So that will be a single displacement. Well, the iron will try to replace the sodium. And then on this one, we've got two compounds again. And the magnesium and the calcium have switched places, so that's a double displacement. Now here we have two smaller substances combining to make a larger compound, so that's a synthesis. And then here in number 6, this one would be the opposite. This one's a larger compound splitting into smaller pieces, so this one is a decomposition reaction.